Okay, in the last video I lied to you. I said it was our last video, but it wasn't. It got a little too long, so I want to look at some examples in this final, definitely our last video of the year. I want to start by kind of chatting about what we talked about in the last video, because I made a small little error. Not a huge one, but a small one. I combined two different conventions for our transformations. So in the last video, the first thing we did was we talked about the parent functions for sine, for cosine, for tangent, and then we just kind of briefly talked about these transformations, which we're going to use in this video. Here's what I did that I want to kind of correct. When we have been doing transformations in the past, we have done A, H, and K, and we are just adding in this B, this horizontal stretch, compression, reflection. I kind of combined two different conventions. We can still use the A, H, and K, but another convention that is often used is A, B, C, D, which is where this CD and this CD came from. So it's not that it was wrong, it's that we don't really, I have A, B, H, and K in my general form, and then I use C and D, but didn't tell you what C and D meant. So C is your H and D is the K. Why do we switch them? I don't know. And you'll see it both ways for the trig functions. So what we're going to do is we're going to take a look at a couple of our trig functions, and I'm actually just going to use the worksheet, and we are going to start by doing a sine that has just one transformation. So notice in this one, let me make it a little bigger for us here to give me lots of room. Our A value is 1 because there's nothing in front of the sign. Our B value is 1 because there's nothing in front of that parentheses. Our C value, remember it's x minus C or x minus H. They're the same, we're just calling it C this time. So I always take the opposite, so negative pi. And then our K value, or sorry, I'm combining them again. The D value is 0 because there's nothing added off to the side. So again, A is coming from right there, B is coming from right there, C is coming from right there, but it's always the opposite, x minus H, theta minus C, and the K value is coming from right there. There's nothing there. All right, so what I'm going to do is I'm going to start with my key features. So I'm going to come over here to my key features using these. The amplitude is 1 because the A value is 1. The period of the parent function for sine is 2 pi. And since B is 1, which is the same as the parent function, that doesn't change. The phase shift is the C. So C is negative pi, so it's going to move to the left pi. And then our vertical shift is the D value. It's 0, which is the same as our parent function, so none. And then the midline did not get moved. These two will go together. If there's no vertical shift, it's y equals 0. If you go up 3, it's y equals 3. If you go down 10, it's y equals negative 10. So those two go together. All right, now I'm going to do the table of values for my parent function for sine. So using my quadrantal angles, going around my unit circle, my computer's doing that thing where it wants to go super slow, and so it makes all my writing look even worse than normal. So my quadrantal angle, sine starts at 0, goes to 1, back to 0, down to negative 1, back to 0. Okay, you're going to get to where you have that memorized. Now, transformation-wise, the only thing that changed from my parent function is C. C affects the domain. So I am going to add negative pi to my domain. I am going to add negative pi to my domain. So right here, this is my c value. I'm adding a negative pi. I'm subtracting pi. So 0 minus pi is negative pi. Pi over 2 minus pi is negative pi over 2. Pi minus pi is 0. 3 pi over 2 minus pi is pi over 2. And then 2 pi minus pi is pi. So these are no longer valid. No change to the range. Okay, so now this is my normal sine. 0, 1, 0, negative 1, 0. And what this is going to do is move all of these values to the left pi. Gotta keep going. There we go. So what was 0, 0 became negative pi 0. What was pi over 2 comma 1 became negative pi over 2 comma 1. What was pi comma 0 became 0 comma pi, and so on. So this is one period, one cycle. And then it's just going to continue. It'll do a better job than me. And it's going to continue going this way. My pen's doing that. I don't want to write for you thing. So do a little bit better job than me. That should come up and hit that. I've got to at least make that right. All right. And that's it. That's it for that one. Okay. Now, we are going to skip 2, and we are going to go to number 3. In number 3, we have a amplitude change, because our A is 2, and we have a phase shift, because our C value is pi over 4. Okay? And I want to do cosine, so that we're starting with that cosine. So again, on this one, the A is 2, so that's different from the parent function for cosine. The B is 1, that's the same, so there's no horizontal stretch, compression, or reflection. The C is pi over 4. Remember, it's theta minus C. So that's going to go to the right, pi over 4, and the value for D is 0. So that's the same as our parent function. So the things that are going to change are my amplitude, and I'm going to have a phase shift. So the amplitude is 2. The period stays the same because B is 1. The phase shift, I am going to the right this time. Pi over 4, I think it was. Yeah. No vertical shift, which means my midline is the same. Okay. Now I'm not going to do this one all the way through. I'm just going to help you get it set up and started. And then I'm going to let you try this one on your own. So my normal cosine, let me do that again so I have more room. Starting with my quadrantal, so 0, pi over 2, pi, 3 pi over 2, 2 pi. Cosine starts at 1, then goes to 0 to negative 1, back to 0, back to 1. All right, so the A is a horizontal flip, compression, or stretch. That is going to affect the range, and I'm going to multiply. B is 1, so it doesn't do anything. If it was anything other than 1, I would need to to divide the domain. The c is pi over 4, so I'm going to add pi over 4. Notice for a, you're going to multiply. 1 times 2, 0 times 2, negative 1 times 2, 0 times 2, 1 times 2. For c, you're going to add. So 0 plus pi over 4 is pi over 4. Pi over 2 plus pi over 4 is going to be 3 pi over 4. You're going to get good at working with fractions, or you're always going to have a calculator on in your hand. Pi plus pi over 4 is 5 pi over 4. 3 pi over 2 plus pi over 4 is going to be 7 pi over 4. I'm just finding common denominators. 2 pi plus pi over 4 is going to be 9 pi over 4. I'm going to let you graph that one because I want to take a look at ones where I am changing the value of b, because that's different than anything we've done before. I'm just crossing these out to remind you these values are no longer valid. So you're going to plot pi over 4 comma 2, 3 pi over 4 comma 0. You're going to see that what happens there is it's stretched from the top and the bottom, and then it's moved to the right pi over 4. By the way, right here, this is pi over 4 because it's half of pi over 2. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and so on. Okay, let me pick a good one. Let's do this tangent one first, even though it's not b. And then let's do this sine one. This number 9, if you don't want to do number 9, it's okay. Just because all the fractions makes it a little bit kind of a pain. But let's do tangent first. I was trying to decide. Yeah, let's do this tangent first. Okay, so we are going to make ourselves a little bit bigger here. Don't you wish you could make your paper do that? First, decide what our a, b, and c are. So a is 1/2, b is 1, c is pi over 2, and d is 0. And actually, that one's not as interesting as I wanted it to be. I'm not going to do the whole thing, but I'll help you get it set up. I want to spend time on more interesting ones. First of all, the amplitude and midline really don't make sense for tangent. They're not defined for tangent because tangent doesn't oscillate. The period for tangent is pi, and since b equals 1, which is the same as the parent function, that doesn't change. Phase shift, I'm moving to the right, pi over 2. And vertical shift is none. Now for this one, when you set up your table of values, you're not going to use your quadrantal angles. You could, but it's really helpful to have the pi over 4s. And since our undefined are happening at negative pi over 2 and pi over 2, let's do those because it just shows me a little bit clearer what's going on. Oops, that was supposed to be a 4. Okay, undefined here. I'm just going to write UND for undefined. At negative pi over 4, it's negative 1. At pi over 4, it's 1. And at 0, it's 0. Again, you're going to get to where you memorize those, but look at your unit circle if you need help. All right, so again, the A is always going to affect your range, and the C is going to affect your domain. Now, when you multiply undefined times 1/2, it's still undefined. Okay? Yeah, and then, sorry, my brain wasn't working there for a second. And then negative 1 times 1/2, negative 1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2. Undefined times 1/2 is still undefined. And then for the c, I'm going to add pi over 2. So negative pi over 2 plus pi over 2 is 0. And I'm going to let you do the rest. Let's go down and look at number 8. And then we might backtrack to 7. I know we're getting a little long on our video here. Yeah, but that's okay. If you don't need it, then don't watch it. All right, so number 8, your A is 4. Your B is 2. See, this is the first one where my B is not 1. C is pi. And D is 1. So notice I have 4 transformations here. My amplitude is going to be 4. The period is going to be cut in half. You're going to divide by B. Because when your B is bigger than 1, you're compressing from the outside. So that's going to squeeze it in, and it's going to finish the full cycle faster. So that's going to be pi. And then C is pi, so I'm going to the right pi. Vertical shift is up 1. So the midline is y equals 1. Starting with my parent function, its sine, so I'm going to use my quadrantal angles. Sine starts at 0, 1, 0, negative 1, 0. And I've got 4 things I need to take care of. Now here's the thing, guys. You always have to take care of A and B before you take care of C and D. Always. Always, 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 always. Because you need to do those stretches and compressions before you move. Okay? So for A, it's 4. I'm going to multiply by 4. For B, it's 2. This is tricky. You're not going to multiply by 2. You're going to multiply by 1/2. You're going to divide by 2. So I'm going to divide everything by 2. Because you're pressing in from the outside. It's going to squeeze everything closer to the origin. So I'm dividing by 2, not multiplying by 2. Okay? The C value is pi, so I'm going to add pi. C affects the domain. So adding pi, adding pi, adding pi. 4, 5, 6, 7. And then for the D value, that is raising us up 1. So I'm going to add 1. Okay, here we go. We're going to actually plot these. So I'm using the numbers on the outside. These are no longer valid. So pi comma 1, pi comma 1. 5 pi over 4 comma 5. So 1, 2, 3, 4, 5 pi over 4 is right here, comma 5 is right there. 3 pi over 2 comma 1. 7 pi over 4, so this is 1, 2, 3, 4, 5, 6, 7 pi over 4, comma negative 3. And then 2 pi comma 1. So one complete cycle is doing this. And then that's just going to pop right back up and come right back down. And this is going to come down to negative 3, back 5 back, and it's just going to continue doing that. And I could keep going if I wanted to. And I could keep going again if I wanted to. But I won't. I'm just going to end it right there. Okay, so that is our sine with 4 transformations. Again, number 9, kind of unnecessarily complicated because of all the fractions, so you can skip 9 if you want. I just want to actually talk about the period for this one. For tangent here, my A is 3, my B is 2, 2, C is 5 pi over 4, and D is negative 2. So we have 4 transformations here as well. Here's what I want to talk about. Here, when my B was 2, for the period, I did 2 pi over 2 because 2 pi is the parent function. I'm splitting that in half. Do you see how I split it in half? I'm completing 2 complete cycles here. 1, 2. I'm completing 2 complete cycles in the amount of space I normally would have completed 1. For tangent, the normal period is pi, so that gets divided by 2. Okay, so I'm not going to do 2 pi divided by 2, I'm going to do pi divided by 2. Same concept, but the parent function for tangent, the period is pi. The parent function for sine and cosine is 2 pi, so I do 2 pi divided by. And that is it for our final video of the year. That was a long one and a little bit of a confusing one. I really wish we could sit and just do some of these together, but it is what it is. Your pre-calc teacher will get that joy next year.